Good evening, all of you. Once again, in the day fourth of this faculty development program on recent trends in 5G and 6G wireless communication. Today, our guest is Dr. Avatar Singh. He is the associate professor in Adama Science and Technology University, Adama, Ethiopia. He is also the chief researcher in Nasim College, the Adama Science and Technology University, which is situated in Adama, Ethiopia. He is working from there from February 2020 till now. Earlier, he has worked as assistant professor in VLSI in C.V. Raman College of Engineering, which is situated in Bhubaneswar, India, from January 2019 to January 2020. He has completed his PhD from National Institute of Technology, Silchar, Assam in September 2019. He has pursued Master of Technology from Thapar University, which is situated in Patiala, Punjab, India, in November 2011 in VLSI. He has done my Master of Science from Barkatullah University, Bhopal, India, in July 2007. He has done Bachelor of Science from Mamta Jyotibai Rohilkhand University, Bareilly, India, in 2005 June. He has almost 51 one publication and 435 citations. He has collaborated with faculty members on electronic simulated and hardware projects. His contribution to planning appropriate and engaging lesson for both classroom and distance learning applications. He is the member of capacity of secretary in MSc Electronics Engineering Curriculum Revision Committee and member of Department Academic Council. He is technical committee member of ICARMET, which 2015, which is the IEEE sponsored international conference. He has participated in many various professional development programs. He has also developed physics laboratory experiments for standard 10th and 12th and repaired computer and electronics equipment at ODA Special Boarding School, Adama, Ethiopia. He has been appointed as a leader of a special interest group, VLSI Nano Devices. He is the member of Department of Academic Council ASTU, Adama, Ethiopia. He is also the member of Department Research Committee in his college, ASTU, Adama, Ethiopia. He is member of PG Exam Committee in ASTU, Adama, and Secretary of Course Development Committee for PG in Electronics Engineering in ASTU, Adama. Today he will present his presentation, and I will request our Dr. Avatar Singh sir to please start the presentation.
Okay, thanks a lot, sir, for introducing me. So you made me a host. Shall I share my screen?
You can present from there, sir.
Okay, sir. So my voice is coming?
Your voice is audible, sir.
Then it's okay, everything. Thank you.
Mm.
Okay, so thank you for inviting me, PJ sir, madam, Vani madam, and all others, and our respected faculty members. So as assigned to me, so today I'm going to present something on, although you are also good in these fields, because these are the basics, right? We know everything. We are teachers, we are teaching from last many years. Might be this is like useful for the persons who are newly joined, because electronics is very vast. We are coming and it's not possible to complete in one life even. Believe me, because if you are going to study everything from semiconductors to wireless communication to artificial machine learning and all those things, so the other thing. So just although our always task is to cover maximize as possible, but yes, our major thing should be what is the new trends, because what I believe, because there are two types of things, because we are teachers, right? Because this is the FDP, so our main target is to publish some papers, because we need some because this is helps in our promotions and all those things. Although my specialization is particularly, I'm working in semiconductors. I have a good background in semiconductors and VLSI and all those things. Wireless also I started. It's good
अवतार
because
साहब
जी पीजे सर नमस्कार.
नमस्कार, कैसे हैं?
मैं अच्छा हूँ सर. थैंक यू सर आपका।
ठीक है, ठीक है।
जी थैंक यू, आपसे बात करता हूँ। थैंक यू, बहुत बहुत धन्यवाद आपका सर।
हाँ, ठीक है, बाद में बात करेंगे, ठीक है।
जी 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 सर, जी सर, जी सर। So, what we are doing actually, our major target is to just publish papers, definitely, because we faculty, we need papers. Even our students publish, we publish, we need papers. And the second thing that we can give some, we can pass some knowledge to our students by which they can able to get the employment. Because see, they are investing the money, we understand, right? They are investing the money, and like this is also now education is also type of an investment. We can't say, because this basically after the 12th education is an investment. Before 12th we can say that this is for the general growth, but after the 12th this is an investment, because now education is also very costly. You know the things, you are in Hyderabad, you are all from the country India. Okay, so we have to think like this. So this is so just I try to make it very simple. Okay, and as simple as possible. Like, so even the person is not from this background for wireless communication, might be only some electronics, also even not from electronics, he can able to understand the grasp the concepts. Okay, because after that what we need the foundations. After the building is created by their own thoughts, by their own things, by their own beliefs, right? Okay, so we will going to start it. So today's topic is just we are going to discuss something about the MIMO and massive MIMO antenna for next generation wireless devices. So if we see nowadays, everywhere we need like wireless. If you need now, electricity is also wireless. Everything is going to be wireless after some time. Whatever the impacts, whatever the benefits, all are there. Okay, and this is the research. Research means we have to search again, then again search, then again search. This is the research. Means there is a no non-stopping phenomenon. Like we have to search, 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 search. Again we have to search, because like the world is moving. Artificial intelligence now, all those things. It's like very means competitive is there. Like nothing is easy nowadays, right? Generally for the teachers, for everyone, even we know the things. So okay. So we have seen now cable modem, hard disk, web camera, MP3 player, desktop PCs, digital cameras, smartphones, wireless media players, laptops, IP camera. Everything is giving nowadays wireless. Nothing is without
Sorry for
wireless. Even
interruption, sir. Sir, can you please
please,
put your slide full screen, sir, please?
sorry, sorry, sir.
Yes, sir.
Yeah, I forget, sir. Thank you for reminding
Okay.
me.
Okay, sir.
Now it's okay, sir. Yeah.
Now it's clear.
Yeah, yeah. So if we see nowadays, if you see GPS system, everything is wireless. Okay. So this is the like there is an because if you want to grow, you have to grow yourself with the technology. If we are, because what happens to before, like the companies, let's just, I have seen that day before yesterday, there are many companies like we know HMT, we know Kodak. They are not ready to Nokia. They are not ready to change themselves. So now they are absolute. No one is there. So just the change is the nature. And then like we have to, like this is the journey and the change is the journey, we can say, right? So we have to change, like we have to update ourselves every time. Update ourselves every time. So first I'm just going, because the things is wireless, from where the wireless is going to be start. Wireless is starting from the antenna, right? Antenna. This is the basic antenna. We can't like say, because antenna is everything in the wireless, right? So an antenna, everybody knows, is a structure affiliated with the region of transition between the guided wave and free space. Might be this is little bit difficult. So we'll come to the very basic. Like antenna is something which transforms an electrical signal, or we can say converts electrical signal into electric power into electromagnetic waves. Electromagnetic waves, or simply radio waves. Right. This is the very basic application of, like, definition of the antenna. Okay. So basically antenna, when we were a child, we know about the Yagi antenna, single dipole antenna, then double dipole antenna, then many antennas are coming. Now if we are seeing in the mobile, the antenna is just like a one dot. Like if we see, like different materials are coming, or now the capacity of antenna is also, like, many things are came, right? So before, I remember in my home, we are getting it like big antenna, and we are just adjusting the signal for the antenna. Yagi antenna, that time it was came. Okay, so these are the very big, very big. We generally we are making with the aluminum and all those things, but the transform is coming from that. So that's a signal from a transmission line or the guiding device, hence the term guided wave. That's why we are saying it a guided wave, like a coaxial cable. Coaxial cable we have seen, like we are using for the dish, means which is round, and inside there is a one ground cable, and then another cable is just wrapped on the like the inner plastic part. So is sorry. So is given to an antenna, which then converts the signal into electromagnetic energy to be transmitted through space. Hence the term free space, means from the sky. So now I'm directly, because antenna, now we are coming diversity, because it's a very, if we are starting from antenna to all those things, it takes a lot of time. Right. So I'm just coming directly to the major point, because we have to introduce some research topics. Might be, I will try my best. Okay. So diversity. So if we see, especially in urban and indoor environment, like in our buildings, in our homes, where a lot of things are placed, means many walls are there, cars are there, parking, trees are there, right? So especially in like in the cities like Hyderabad, like Delhi, Mumbai, there is a no clear line of sight. Means we can't able to see the things directly, right? If the directly is, we can put the signal directly, we can transmit. But here is a more reflection, diffraction. There's a, because the signal is not going like straight. Okay, so between transmitter and receiver. So instead, the signal is reflected along multiple paths before finally being received. So diversity is a technique by which we transmit many copies of the signal or versions of the signal, but affected with different fading over time frequency. Means diversity, what is diversity? Basically, we are sending the copies of signal, like many copies of the signal, like one copy, because we believe that the receiver not received the exact amount of the signal which required for the proper like we can say proper transmission, like proper signals, like we can say like some definition of signals, right? So what we are doing, we are sending the copies of signal, and this sending copies of the signal is known as diversity, right? So basically, and there are many type of diversities are there, because the fading, what is fading? There is the word is fading is coming again and again. Fading means like fade, the things are going to be deteriorate, like they are going to be weak. So this is known as fading of the signal. So if we see single link, single means just we are using the single link, we are sending something and receiving something. Then there is a multiple links. So nowadays is used right for the multiple. It means we are sending multiple signals. So this is known as diversity. So diversity requires additional hardware, definitely, because if you are sending the things by the single, it's like before hardware what we have already available. Now diversity is also available. More research is already going on this area, but diversity requires additional hardwares. Definitely put more cost and integration versus a single antenna system. But due to the commonality of the signal paths, a fair amount of circuitry can be shared. So diversity means send the same message. We are sending the same thing, but by the replica of a message. Like we are using the copies of the message through one communication channel, might be with different characteristics, or might be we sending it by different ways. So we assure that our signal is 100% reached there. So to overcome fading, I already told you, fading means like the signal is getting to be weak when we are sending it. So to overcome fading, because if the signal is less, definitely the signal is less, the response is less. We are not getting the proper response. So to overcome fading, to combat co-channel interface, and to avoid error bursts. Error burst means we are sending the things, many errors are coming. So combined of all of the errors are known as error burst. So diversity schemes, basically time diversity. Now there are type of diversities are there. How we are sending: time diversity, frequency diversity, space diversity, and polarization diversity. So time diversity means multiple versions of the same signal are transmitted at different time instants. Like one we have set now, after some time, right? So frequency diversity means we are sending the signal with several frequency channels. Like we have given the paths like this, one this, like several frequency channels or spread over a wide spectrum. We can do like this. Then the space diversity means the signal is transmitted over several different propagation paths. Like frequency is we are giving on the frequency channels, different type of a frequency we send. But space means from different parts we have sent, from different ways we have sent, from different angles we have sent, like we can say, right? So in the case of wireless transmission, it can be achieved by antenna diversity using multiple transmitter antenna. Not only one, we are using multiple transmission antenna. So this is known as transmit diversity, and or we can say multiple receiving antennas also, because if we have multiple, this is actually known as MIMO, right? multiple input, multiple output. So we are sending more number of like signals using transmit diversity and the reception diversity. So this is the thing. So multiple versions of the same signal are transmitted at different time instant. What is the time diversity? We just have to see about the, just one by one we will discuss. Then we are coming to the MIMO, then massive MIMO, then the search engine MIMO. So multiple versions of the same signal are transmitted at different time instants. Like when we have sent like before 1 second, then another, means not microseconds, we can say. Not 1 second is too much time, right? Microsecond, even a picoseconds. So averaging the fading to the channel over time by using. Now what we are doing, all the signals are taken by the receiver, and then there is a digital signal processor is there. So everything is going to be changed there. So the channel coding and interleaving, sending the data at different times. So alternatively, a redundant forward error correction code is added. Okay, because definitely we have to check where is the error. We are using some error techniques, like, so just we are putting some error correction code is also added in this, and in means it team of it is actually spreading in the time by means of bit interleaving, like some bits we are sending. So error bus might be avoided by using time read, but still we are getting it. We simplify, although the level is reduced, but we can't say that it's 100% like 100% removed, right? Then there is a frequency diversity. The signal is transmitted using several frequency channel or spread over a wide spectrum that is affected by a frequency selective fading. So transmitter, the figure is already we have, like, if you see, sorry. If you see, this is the path 1, path 2 we have sent with the different frequencies. So transmitter, this is the receiver. Then we have polarization diversity. Polarization means we are sending with a different type of like we can say like some rotating like a pivoting, like some planar polarization, some circular polarization with different angles, like different polarity, the things we are sending also, like this, right? So this is very useful. Even we are generally the space aircrafts and the aeroplanes and the things which is there is a no obstacle. Generally, they are utilizing this polarization diversity. So means in the polarization diversity, what we are doing with different means two signals are going to be transmitted with RF energy divided into horizontal and vertical planes. Horizontal also we have sent, vertical also we have sent. So both the signals are like received by the receiver in an undistorted manner, and thus the signal is good enough. Like that's why, but in this the major problem, we should not get any like the hurdles like the buildings and all. That's why it's better in space. So okay, so in some more advanced system, instead of planar polarization, circular polarization is also used. Okay, so means circular means rotating type of a thing. So here like both counterwise and anti-clockwise, both we are sending. So they have received, and but generally we are using it, utilizing in the like line of sight situations for spacecrafts, as I have already told you, where should be unobstructed path between source and destination. So this is the type, like if you see, this is the one, okay, and this is the, if you see, this is clockwise, this is one anti-clockwise. We can left hand circular polarization and the right hand circular polarization. So there are two transponders are there, both are received. So this type of a signals we are generally using. This is the polarization diversity, right? So then space diversity. Now MIMO is coming under one of type of the space diversity. Many copies of the transmitted signal affects with different fading over the space. So we use multi-antenna systems. We are not using now here. If you see, we are utilizing most of the time single antenna, right? In all this, but here now we have started with the multi-antenna system. Might be we are putting more antennas at the receiver part, might be transmission part, depends which type of a which type of a application you have. Many things like there, right? So because unnecessary the if we are using the although nowadays if we see that the massive MIMO and all those are very cheap, okay, but if we are thinking, if we are not going to utilize, why we are not utilizing CISO, like CISO, CMO, CMISO, and MISO, like, okay, it depends on the type of application. So we use multi-antenna system at the transmitter diversity, at the receiver reception diversity. At both of them, it is known as MIMO, multi-input, multi-output. So this is our topic of today. So space diversity, if we see transmitted signal transmitter, if you see now, if this is, so here we have just two receivers are there, right? So if combining here, recovered signal. What we are doing actually, there is a digital signal processor everywhere. We are utilizing here digital signal processor, which compare the signals, taken the, it means the same part they have to remove and the might be overwrite. Okay, depends. They remove or might be overwrite. And the another part might be what is not required, what is missing from the one, they have taken from the second, like this. That's why they are good. So transmitted signal again, if we see, so transmitter 1, transmitter 2, receiver 1, receiver 2. So this is also can be possible, hitless switch. So types of space diversity now. Now there is a CISO. CISO means single input, single output. MISO means multiple input, single output. SIMO means single input, multiple output. And MIMO means multiple input, multiple output. So if we see the CISO, so CISO is like this, means single input, single output. Like stands for this. So it uses one antenna at the transmitter and one antenna at the receiver. So CISO channel is more susceptible to problem caused by multiple effect. However, it is cheap to implement because only one antenna we are utilizing. So definitely it is going to be cheap. So for CISO system, the capacity is given by Shannon formula already we know. This is just to measure the capacity of the signal, like some related with the capacity. Okay. So this is one signal we have sent only CISO. Now multiple SIMO means SIMO stands for single input and multiple outputs. It uses single antenna at transmitter and multiple antennas at the receiver. So SIMO system is preferably used in uplink type of a system. Now multi-input single output means multi-input single output means there are multi-input multi antenna at the transmitter part and one single antenna at the receiver part. So this is multi-input single output. So transmit delivery at the receiver, the combined signal is separated units to individual component using signal processing techniques. Okay. So this allows that means if you see antenna and like this, so wireless communication is the branch where we are combining all the things. Like suppose antenna we have to prepare. So what we need advanced materials. We need semiconductors. We need microstrip antenna, something like this. Some different materials we require, right? Now another part, digital signal processor is also there. We can't omit them. Then processor is also there. Then VLSI is coming. So like electronics, if you say no, like nobody means what I believe, nobody can master of a single field, like because it's a vast, very vast. Now, if we are just thinking about the machine learning and all those things, but still machine learning needs some hardware. Now the things are started on the hardware accelerators, right? You know, like machine learning based hardware accelerators using FPGA, because FPGA is comparatively, although the topic is wireless, but everything is interlinked, right? There are many things are there. So just might be in another time we will discuss. So at the receiver, we combine the signal into its individual component using signal processing techniques. So this allows the receiver to extract information from each of the individual signal that were transmitted. So this is known as MISO. Now the last one is MIMO. MIMO means multi-input, multi-output. If you see, CISO means single antenna, single here. Here is SIMO means single antenna, double here. MISO means multiple here, not double, multiple here. This multiple input and single output, and there is multiple input as well as multiple output. So this is the things nowadays we are using. Now we are covering our topic, like just we have made why MIMO. So MIMO stands for multiple input, multiple output. It is a technology used in wireless communication nowadays, systems to improve data transmission and reception efficiency. I remember in around 2018 or 19 already, like if we see the mobiles, it are coming with 2 by 2, means 2 by 2. If you see 2 MIMO, like 2 by 2 arrow MIMO, something is 2 array MIMO or 2 by 2 MIMO. So it means 2 input antenna, 2 output antenna they have. Now, if we are working with the massive, so massive, I think mobile till not came, because Apple also iPhone 16, I believe 8 by 8 is there. Okay. So with some processors are coming, like some modems and with the massive MIMO. I heard like 128 by 128 arrays already means somewhere in Hyderabad is installed. I heard, I'm not sure. So now the things are coming, because if the number of antennas are more, then definitely the signal is very powerful, and definitely the data rate, we can able to achieve the 6G communications. We can able to go more frequencies, like more data we can able to transfer the things like. So MIMO stands for multiple input, multiple output. It is a technology used in wireless communication systems to improve data transmission and reception efficiency. MIMO uses multiple antennas at both the transmitter as well as at the receiver ends of a communication system. So this is type, like this is also the MIMO. This is also the type of a MIMO, if you see. So like multiple antennas, transmitter, then different paths. Because if you see, this is also giving the signal to this. This is also giving signal here. This is also giving signal here. So all the receivers have from one transmitter, transmission and transmitter antenna, it is connected. Like this same thing here, same thing here. So all are connected together. So if you see the array is like 3 by 3, like we are saying, but it's more signals are coming. Like so the things are like this. So this is why MIMO is now is in like demand, and also it's like very popular. The use multiple transmitter and receiver to transfer more data at the same time. MIMO technology takes advantage of a radio wave phenomenon called multipath. Multipath means from different paths. This is known as space diversity, right? So multipath, where transmitted transformation bounces off walls and other objects, because might be some wall is there, some car is there, some tree is there. So might be one signal will not reach, but another signal will reach. So in this way, we can able to complete the signal. This is the major advantage of the MIMO. So reaching the receiving antenna multiple times by different angles. And because what is our target? Our signal has to be reached. This is our target. Like, so this is the transmitter width and MISO, CISO, MIMO and SIMO, like something. So receiver with one several antenna like this. It's some figure is there just. So if you see, this is type of an array we are utilizing. So this is the 2 by 2 array, like 2 antennas at the transmitter, 2 antennas at the receiver, 3 antennas at the transmitter, 3 or 2 antennas at the receiver. So there are array, means it depends on the type of antenna and the requirement, like this we are using. So most common MIMO configuration is 2 by 2, 2 by 3, 2 by 4 and 4 by 4, right? Because of the semiconductors like fabrication and all those things, if started in India, then it's going to be very, very cheap and very, very easy things, like, you know. So spatial multiplexing, there is a one word is coming in between, so that's why I just want to explain that word also. So spatial multiplexing or space division multiplexing or SMX is actually a multiplexing technique. Multiplexing, we know what is multiplexer. Multiplexer means many into one, means we are giving many signals and we are getting one at the output. This is the only multiplexer, nothing else. Using the select lines, we can select out of many one, right? So generally this type of a multiplexing techniques, like spatial multiplexings, we are generally utilizing in fiber optic communication and other communication technologies used to transmit independent channels separated in space. So MIMO increase data rate via space multiplexing by allowing to transmit different streams of data simultaneously on the same resource block by exploiting the spatial dimension of the radio channel. If you see like this, if you see the figure, so means this is known as spatial. If you see original data stream is 010110, so we are using it because many signals are coming at the output. So MIMO can, why MIMO, why we need the MIMO actually. So MIMO can exploit multiple transceivers at both the enhanced node B base station BS and the user equipment UE. Increase the data rates of the mobile system. Means what are the advantages of the MIMO we are going to discuss now. MIMO includes data rate via space multiplexing by allowing to transmit different streams of data simultaneously on the same resource block by exploiting the spatial dimension of the radio channel. MIMO enhance link reliability in challenging propagation conditions when the signal strength is low and multipath conditions are challenging. Thus MIMO lower bit error rate. That's why it is more popular because of high efficiency, high throughputs. So MIMO improves the robustness of the data transmission via transmit diversity. If you see here, like here also same signal is going, like means there is a difference between the we can say diversity and this, right? So here if we are seeing the signal, the same signal, it means we are getting like this. So this is the things, and definitely the gain in reliability and gain in throughput, everything is going to be happen. So each transmit antenna transmit the same strip of data. This increases the signal to noise ratio definitely at the receiver side, and thus the robustness of the data transmission, especially in fading situations, right? So MIMO advantages, major advantage of MIMO: higher capacity, increased data rate, lower bit error rate, increased coverage, improved position estimation. MIMO disadvantages: computational complexity and channel modeling complexing. So these are the MIMO applications. If we see, so everywhere we are utilizing the MIMO because everything depends on the wireless communication nowadays. Nothing is possible. Nothing is possible without, like we can say, wireless communication. If we just give you the broad idea of the MIMO, MIMO is just like a 4-lane road. Like suppose you are on a single road. So all the traffic is on the single road. But when we are talking about the MIMO, like you are getting the 4-lane road. Like if you are going from somewhere like highway, there is a 4 lane. So 4 cars immediately go together. They have different lane. So definitely the speed is increased because no one is coming in between them, right? 4 lane is there. And different antenna means you understand my point, right? So this is the MIMO. Like just when the MIMO is coming, just you have to put in your mind, like we are talking about the 4-lane antenna, 4-lane routes, right? And definitely the data throughput is going to be data throughput is going to be increased. And like suppose if you are sending 2 balls simultaneously, okay, so definitely before you have 1 ball you are sending and another ball you will put in pipeline, then you will send. But now parallelly you are sending 2 balls, right? So from the receiver to the transmission, it's from the transmission to the receiver, it will, like the time is going to be reduced, which is the requirement of the like current scenario, right? Because we need everything in a lesser time. So this is the thing. So that's why sorry. Okay. So communication network applications such as broadcasting network, cellular network, satellite communications, like MIMO applications where we are utilizing is narrowband applications where limited bandwidth and lower data rate, higher performances, pager text messaging applications such as BlackBerry before is coming now. Hello. Yes. I think some camera, some mic is on. Sir. If you make it off, it's good, sir.
Kumar sir, please mute it. Sir, please switch off your mic. Kumar sir. Sir, please mute it.
Okay, no problem. We understand. Sometimes it's happened. No problem. So now we just discussed something about the MIMO. Now there's a time for the multi-user MIMO, right? MIMO we understand. Like just when the MIMO is coming into mind, it means 4-lane road we are utilizing, right? Because everything is dependent on the base transmission systems. I mean, many things are linked actually. It's not possible to discuss everything into. And if we see MIMO, where we are utilizing MIMO, if you see the Wi-Fi 4 LTE network, before there is a LTE network is coming, like before 4G in the time, we can say somebody is asking this is the 4G network. Okay, so now we are utilizing 4x4 in Wi-Fi 4 and LET like LTE. We are utilizing 4x4. Whatever the mobiles are coming at that time, if you see their configuration, so you will see that it is written in wireless, like if you go for the particular for the wireless, their what we say wireless parameters or wireless things. So if you see there, you will see that 4x4 we are utilizing there. Okay, so now after that we are getting multi-user. Okay, so multi-user, actually what we did, if you see here, there is only single user we have, right? Multi-user, now we can send the signal, like now just like we are utilizing the data, right? All the telecom operators, they are giving the data. So now they have utilizing the method of multi-user. And everything is there. So multi-user means like multi-user, multiple MIMO means multi-user, multiple input, multiple output. Is a technology used in wireless communication systems, particularly in Wi-Fi networks, because Wi-Fi broadcasts everything. Now, which like might be iPad, everything you can able to connect with the Wi-Fi. Then how much signal as per the data you can take. So multi-user MIMO system. Okay. So particularly we are utilizing in Wi-Fi networks to increase network capacity and efficiency. So like we know, it allows a wireless access point to communicate with multiple devices simultaneously instead of serving them one at a time. So like this, we can able to utilize, because might be sometimes one person is not utilizing, another person is using. So we can able to utilize the resource for 24/7, right? So single user MIMO, then multi-user MIMO, then open loop MIMO, open loop MU MIMO, closed loop MU MIMO. Many things are there. Like closed loop, we are the more security passwords are there. So how MU MIMO works actually? So traditional, what we know is MIMO means single user MIMO is actually like Wi-Fi router communicates with one device at a time. Like you can connect only one device. But now if you see, if you have a Wi-Fi, even you can make your mobile hotspot, right? You can able to connect 8 or 16 devices at a time, right? So this is the multi-user, right? So device, even it has a multiple antennas, but we are utilizing it only for one. So devices must wait for their turn. Might be one device is connected now, after some time the another device is going to be connected, after some time the another device is going to connect, like this. So but when we are utilizing multi-user MIMO technology, so with multi-user MIMO, the router can serve multiple devices at the same time, right? Might be in mobile hotspot 8 you can utilize at a time. Okay, so by using its multiple antennas, so it separates the data streams spatially, allowing different streams to be sent to different devices simultaneously. So definitely, and then in this also efficiency is going to be increased, because we are utilizing, if one device is not utilizing the data, might be it's not like it's in off state, or might be not, nobody is using it, then another device will use. Yeah, but it is some constraints are there, we will discuss later on. So multi-user MIMO is particularly effective in environments with multiple devices competing for bandwidth, right? So such as homes, office, or public spaces. It reduces latency and improves throughput. So if you see the throughput, latency, performance metrics, if we see something, so multi-user like spectrum is 38.5 we can able to utilize, and power efficiency around 56.5% we can able to utilize. Okay, so if you see the network, everything is clear from the diagram, right? So performance metrics, just the same diagram I have explained here. So throughput MU MIMO allows, means multi-user MIMO allows simultaneous transmission to multiple devices, utilizing available spectrum and antennas more efficiently. Then latency devices, if we see, no longer need to wait in a queue for transmission, right? As the access point communicates with multiple devices simultaneously. Spectrum efficiency, if we see, so separate data transmission for different using avoiding collisions and redundant transmissions. Network capacity, multiple data streams enable more users to connect without significant degradation in quality. Power efficiency, faster transmissions reduce the time a device's radio needs to be active, conversing battery life. So this is something is about the multi-user. So multi-user, if you see the things, so multi-user, like just you, if you put in your mind, like you know, the gun is coming with multiple, like, you know, the things, multiple openings are there in the gun. We barrel gun, we the twice is just, we can immediately we can through multiple balls using that gun. Okay, like bubble, now the bubble gun is also coming like that one. So just if you keep in your mind that multiple roads are there, like four, then this is also known as massive also. Massive is also very near to, like, the advanced version of the multiple users, we can say the massive, right? So this is also, but it's very large. Multi-user might be you have 5 or 6, 10, 8, but in massive when we are talking, so about 100 antennas we have, like more than, there is no definition. Actually, I am unable to find how many, but it is very more. This is the thing. So massive MIMO is just like user, if you see, like array of the things are coming, like there are number, like hundreds of antennas on the receiver end and 100 of antennas are the transmission end. So massive MIMO is just user MIMO with a number of base stations antenna that far exceeds the number of user terminals, right? So in massive MIMO systems, a very high number of antenna elements is used as the transceiver, which allows two major concepts to be dynamically combined. First,
Anup sir? Anup sir? Artha sir, wait for some time, na? Okay. Anup sir?
is beam forming. Beam, we know when we are seeing the projector, then the beam is coming. So this is not the one signal, right? When number of antenna is more, like when we have more than 8 by 8, then we can say the beam can be formed efficiently. More than 8 by 8. This is like given from the books. If we have more than 8 by 8 antennas are there, then we are saying the beam is going to be formed, right? So both brought about the ability of the many antenna elements to focus their energy into smaller region of space. If an antenna system can do this, we refer to that antenna system as massive MIMO. If both things we have, so it means we are utilizing as a massive MIMO. Massive MIMO is mainly applied at base stations. 5G user devices may implement basic beamforming schemes. Okay, so this is just like a massive MIMO channel transfer functions. If you see multi-user MIMO, where number of antennas is much greater than the number of UBs, right? So this is the massive amount of beam point to single user. User one, single antenna only decoded user one data. So this is like massive. So massive MIMO, if we see, this is the like antennas we are getting like this array. So if you see 1, 2, 3, 4, 5, 6, 7, 8, around 9 antennas are there. If I'm not wrong, 8 antennas, 8 by 8. Right, so this is like antenna 8 by 8, we are getting it. And if you see also here, the cables are there. These are the cables to connect the Ethernet. This is a receiver and transmitter. Okay, so massive MIMO is an extension of MIMO and provides advanced antenna technology with multiple antennas on base stations to serve multiple end user devices simultaneously within one-time interval. This advanced antenna technology enhances spectral efficiency, network capacity, and coverage with easily achievable data rates. So origin of the name massive MIMO. Actually, like if we say there is a dear child has many names, there's a famous saying, and it is generally applies to massive MIMO, right? So massive means like many. Massive means many. So the massive MIMO concept originates from the seminar paper. One paper is there, non-cooperative cellular wireless with unlimited number of base stations, antenna. Okay, published by, this is one person, Thomas Margita, in 2010. The paper talks about multi-user system with very large antenna arrays. So then this Mr. Margita published several papers using the LSAS, large scale antenna systems. So there is a no correct name for the massive. What trying to, for this lecture, I'm trying to preparing what is the exact from where it is origin. So the origin is from here only. There is no exact name for the massive MIMO, but yes, we are many antennas, like we can say like large scale antenna systems, like terminology before switching to call to as a massive MIMO. Over the years, many papers have also been published and called it very large multi-user MIMO and large scale MIMO. In recent times, massive MIMO is used by almost everyone in the industry, even some mobiles also might be. In the future, modems, big systems, they are utilizing it because it is indeed a catchy name compared to earlier ones. That's right. So definition of massive MIMO. Massive MIMO is a useful and scalable version of multi-user MIMO. There are three fundamental distinctions between massive MIMO and conventional massive MIMO. You have tried to understand like this. We are getting the like multi-barrel gun. Like there are, like we can say that the machine gun, or might be there are means many openings are there, and when we are firing the bullets, okay, so not one, there are many, like 100 and some like bullets are going. That is massive. This is the thing. Okay, single means massive MIMO. This is the thing. That means there is a no number, like more than 100, whatever the numbers, right? So just this is the concept. What I got, it means that there are too much lanes, not 4 by 4. There is a 1 4 by 4, then above 4 by 4, then above 4 by 4, like this. The chain, like array of antennas, we can say. Like we have 1 4 lane, then we have another 4 lane on up, then another 1 lane, then on the sides also. So we are getting the array of antennas, we can say, right? So massive MIMO is useful and scalable version of multi-user MIMO. There are three fundamental distinctions between massive MIMO and conventional multi-user MIMO. First, only the base station learns the channel matrix. Second, number of antennas is typically larger than number of users. Third, simple linear signal processing is used both on the uplink and the downlink. All these features render massive MIMO scalable with respect to the base section antennas. So again, just one more definition of the massive MIMO. Massive MIMO is a multi-user MIMO system with M antennas and K user per base station. The system is characterized by M greater than K, means very high, and operates in TDD mode using linear uplink and download processing. A more precise definition can be written as massive MIMO is a multi-user MIMO system that serves multiple users through spatial multiplexing over a channel with favorable propagation. When users being mutually orthogonal in time division duplex and relies on channel reciprocity and uplink pilots to obtain channel state informations. So why we use massive MIMO? Okay, definitely we use it for the faster things, for the loss of signals, to get the things to become the higher, to just go to 5G, 6G, and might be 7G in the future, right? So that's why we are utilizing it. So the most important one is the improvement in energy efficiency that results from increasing the antenna gain by bundling the transmitted energy. Doing this also increases the range and reduces intercell interference. At higher frequencies, like in millimeter waves, like millimeters means 10 to the power 6, so it's like this, right? At higher frequencies, there is an additional challenge of higher path loss, but the advantage of smaller antenna size, definitely, because when we are going with the massive things, definitely we are going to reduce the size of the antenna, because we are making more antennas. Like, so at higher frequencies, a large number of antennas elements can be used to generate a very narrow beam, because large number of antennas beam should be narrow, 8 by 8, with large gain and lower frequencies. The large number of antenna elements can be used to generate multiple spatial streams. What are the biggest challenge with massive MIMO? Before we discuss something about the definitions, then why use massive MIMO? Now, what are the biggest challenge with massive MIMO, right? So although it has many advantages, as we have seen already, massive MIMO, like because now there is no any comparison with the massive MIMO. Okay, but still there is always, because when we are moving, there is always search and research. There is a no, this is the endless process, we know. So the data bottleneck, first problem, and another one is the calibration. So there is the potential to create a data bottleneck due to the large amount of data being sent and received by the massive MIMO antenna system as part of the centralized RIM system, requiring educate fiber bandwidth, right? Because we are sending the things, because there is should be some interconnects are there, right? So interconnects are dependent on these things. Like when we are, our brain is very fast, but our hands and legs are not so much fast. Our processor is very fast, but our keyboard, when we are typing it and when we are utilizing the mouse and all those things, it's not so much fast. So the same thing is here, right? So calibration, given the large number of antenna elements, beam forming antennas that are not calibrated properly will suffer from unwanted emissions in unwanted directions. So this is also the things. So beam squint, which is basically jitter of the beam both sides. So what are the biggest challenges with, again, the same topic? So mutual coupling between antenna elements result in energy loss and thus a reduction in the maximum range, right? Irregular arrays in going from theory to practice, because when we are doing the theory, that's a different and the practical is different. We don't know, right? What is the theory? Because theory we are using the laws, but every time when we are going to reduce the size of the things, there are new quantum concepts are coming into existence and we can't able to neglect. Right? Maybe we are using the transmission line. So if we are reducing the distance between the transmission lines, how much? There should be some categorization. After that, some different type of effects has to be considered. So this is like we have to do. That's why when we are going from theory to practice, then many new things are coming to existence. Some antenna arrays will need to be designed in non-geometric shapes. We need it, right? We are not making it like a regular structures. We are making different type of sticks, right? So that may result in dissipating energy in underarrays, because corner effects, many effects are there. Because this is a big, big science, big subject. Like research, there is no somebody is asking me, so how we are getting the research topic? Everywhere there is a research topic. Just you have to open your eyes. On all the ways, there's a research is there, right? Yeah, but the time depends. Like what research needs this time. This is might be the question. Okay, what is the research at this time? We will do so we can able to make our students and ourselves more infallible. We are getting more salaries. So this is the topic might be to discuss. Research everywhere is there is a topic. You ask me everywhere, I will tell you. Okay, but yeah, what is the requirement of the time, need of the time? This is the we have to for this we have to do the more literature survey. Okay, so complexity massive MIMO antenna system represent a new level of complexity from a design, manufacturing, calibration, and deployment perspective. And with this new level of complexity also comes the need for new design and test approaches. So different types of beam forming used for massive MIMO system. So achieving a certain directivity or beam forming requires an antenna array where the radio frequency signal to each antenna element is amplitude and phase weighted. We know when we are sending the things, there is amplitude and phase, right? So there are three possible ways to apply amplitude and phase shifts. One is analog, then digital, then the another one is mixing of both. This is known as hybrid, everybody knows. So what is analog beam forming? The traditional approach used, for example, in radar applications applies on antenna array combined with phase shifters and power amplifiers to steer the beam into the desired direction. Right. So reducing the side lobes to a minimum, the small amount of hardware make this a cost-effective method. Definitely, right? For building a beam-forming array of certain complexity. Typically, an analog beam-forming array is connected to one RF chain generating only 1 beam at a time, and the range of the phase shifter use limits the applicable frequency range. When we are going for the digital beamforming, the more advanced architecture is required, right? Because performs, when we are talking about digital phase type of a things, little bit, difficult phase. When we are talking about, because analog, we know about the phase, but digital, what is the phase? Because the signal is 0 and 1, right? But that's why difficult, little bit difficult when we are talking about the digital. The more advanced architecture performs phase and amplitude weighting in the digital domain. Each antenna has its own transceiver and data converters, allowing it to handle multiple data streams and generate multiple beams simultaneously from one array. In addition to beam steering, null steering for interference detection is also feasible. Digital beamforming requires additional analog to digital converters. This is the one of the things making it challenging at higher frequencies. But we know that the digital signal processor is like easy. Processing in digital is easy. Analog processing is difficult. This is also the point. So hybrid beamforming balances the advantages and disadvantages of analog and digital beamforming. Targeting higher frequency ranges, such design combine multiple antenna array elements into sub-array modules that are connected to a digital pre-processing states. So system designers use hybrid type of like they are combining both, like this analog as well as digital. So that's, we are just balance the flexibility and cost trade-offs, because definitely when we are putting the things, the major thing is the cost to market, time to market. It only defines the things, right? So while still meeting the required performances parameters such as number of simultaneous beams and frequency range. So research topics on massive MIMO. This is might be nearby to last. So it is predicted that there will be around 50 billion connected devices by the end of 2025. 50 billion. Just if you are going to count from 1, 2, 3, 4, 5, 6. So believe me, it will take some years to count 50 billion. Already we have. So the current MIMO technologies associated with it's unable to handle these huge influx in data traffic with more speed and reliability. So what we need the research. We need make it more comfortable. We need make it more cost effective. We need more number of like we can able to make more reliable, more throughput, everything. There is a research is research. So thus the 5G network is considering massive MIMO technology as a potential technology to overcome the problem created by massive data traffic and users. So some of the significant advantages of 5G we already know: data rate, latency, efficient signaling, user experience, spectral efficiency. We are already utilizing it. Like in Ethiopia also it started. India already 2 years back started. Now that 6G will become, but still the proper deployment of the 5G is still, it needs some attention. What I believe might be. Okay, so efficient signaling, user experience, spectral efficiency, energy efficiency, like connections, battery life. Some of the challenges for 5G technology: frequency bands, coverage, cost, device support, security and privacy, availability, cybercrime. So research topics are design of compensation algorithms to mitigate the pilot contamination effect, to find efficient precoding technique for massive MIMO, to find a more efficient and fair scheduling algorithm design, to find more efficient and low complex uplink signal detection algorithm, efficient channel estimation scheme, to combine it with quantum communication with a frequency higher than 300 gigahertz, to explore machine learning and deep learning for massive MIMO. Right. So actually this I have taken from some slides. I haven't mentioned the link because it's just I got on something. Okay, because this is not my like my research area, but okay, it's like, so that's why I might be, we should know the thing.
Hello.
Hello, sir.
Hello, sir. Avatar, sir. Anup, I think signal problem.
So design of compensation algorithm, because just we will discuss something because might be this is utilized, this is good for someone, but okay, we can mitigate something, like we can reduce some time of a using these algorithm, we can able to reduce some costs, the hardwares we can able to reduce. So design of these combination is a good area of research in massive nowadays. Second, to mitigate the pilot contamination effect, since there are limit number of orthogonal
There might be some network problem because it's international. It's
In
from,
Avatar side, sir.
mm,
In Avatar side.
it's international, ma'am. It will
Yes,
come.
yes.
Pilots that can be used in particular time. So the pilot contamination become one of the, so to find efficient 15 minutes. So to find efficient pre-coding techniques for massive MIMO, although the pre-coding techniques, because pre-coding techniques is very important, like we need something like because it is only responsible to increase the throughput and reduce interference and like latency, delays, everything depends on these pre-coding techniques. The area of research. The next one is to find a more efficient and fair scheduling algorithm design. Definitely. We have discussed about the four things: design of compensation algorithm to mitigate the pilot contamination effect, to find efficient pre-coding techniques for massive MIMO. We are utilizing massive MIMO. There are limited number of antennas are there, right? So user scheduling has to be performed with the number of based because we have to schedule everything, right? So massive MIMO system throughput can be increased by only scheduling the user experience in good channel conditions. Might be some channels are not in good condition, so we can able to find that one and we can able to like replace or whatever the things. So but using these scheme, the user at the edge of the cell with poor channel conditions are ignored and never scheduled, right? So to improve overall system performance, a certain amount of fairness must be ensured among all the users. Several research has been conducted to achieve an efficient user scheduling algorithm, but optimal performance has not been achieved. Further research should be conducted to find a more efficient and fair scheduling algorithm design that can provide a higher data rate and guarantee fairness among users. So to find more efficient and low complex uplink signal detection algorithm. This is also one good research area. So in massive MIMO system, due to a large number of antennas, the uplink signal detection becomes computationally complex and reduces the achievable throughput. So here the signal transmitted by the user superimposed at the base station to create interference, which also contributes reduction of throughput and spectral efficiency. So a recent experiment has achieved near optimal performance, but more efficient algorithms are required to realize massive MIMO. One of the crucial areas of investigation is to find more efficient and low complex uplink signal detection algorithm. The next one, to find efficient channel estimation scheme. This is also one of the good subject. So like in massive MIMO for the beam forming data, like for detecting user signal and resource allocations, the user terminal has to estimate signal coming from a large number of antennas at the base station. Furthermore, the pilot overhead also increases drastically. So there's an efficient channel estimation scheme with reasonable pilot overhead is an exciting area to investigate, particular for FDD scheme. So combine it with quantum communication with a frequency higher than 300 gigahertz. And an exciting area for research in massive MIMO will be to combine it with quantum communication with a frequency higher than 300. Now this is the topic which is required by everyone to explore machine learning and deep learning for massive MIMO. So the use of machine learning and deep learning algorithm during massive MIMO channel estimation to predict statistical channel characteristics is an exciting area of research. So means everywhere, if we see now automobiles, mechanical, civil, electronics, computer science, everywhere we are utilizing machine learning is must. Even we are utilizing chat GPTs, Canva, there are a lot of tools we know already. Okay, now the students are just, they are coming with the reports made up of that one. Immediately they are getting, even sometimes also we have to ask the questions immediately. They prepare 100 questions from this, 50 questions, 20 questions. So we have to see, like, we have to make better than these technologies to us. Then because like, you know, the things, the environment is going to be. So this we have to see. So the use of machine learning and deep learning algorithms during massive MIMO channel estimation to predict statistical channel characteristics is an exciting area of research. Several experiments have been conducting recently to explore machine learning and deep learning for massive MIMO channel estimation, user scheduling, beamforming, and signal detection. Some of the important areas to investigate are the fabrication of plasmonic nano-array antennas, optimal channel estimation methods, low complex and efficient precoding and signal detection algorithms, accurate beamforming and beam steering. The study on potential key enabling technology for 6G networks such as terahertz communication, visible light communication, and holographic radio is also an interesting area to investigate. So what are the applications already we are utilizing? Wireless standards if we see, so MU multi-user MIMO in 802.11 ACYX, cellular networks 4G, LTE, 5G, broadcasting. These are all the applications of the MIMO, massive MIMO, right? So improve signal reliability in TV and radio broadcasting, military and aerospace, robust communication in challenging environment, IoT and smart devices enable efficient communication, smart home, and all those things. The application of MIMO on this is 5G networks, enhanced capacity and throughputs, low latency applications such as autonomous vehicles and AR, VR, auto receiver, video receiver, smart cities, efficient spectrum utilization for IoT devices, public safety, reliable communication during emergencies, energy efficiency. Like there are everywhere we are utilizing these type of a massive MIMO. Now the next is antenna design for MIMO systems. This is the major thing nowadays. Like what we need, isolations, like because how we design the antenna, okay, because antenna is everything in the MIMO system, right? So isolation, ensuring minimal interference between antennas to maintain performance. Diversity, designing for polarization, spatial or frequency diversity to maximum data rates. Size and placement, compact designs for mobile devices versus large array for base stations. Common designs, planar antennas, compact and low cost, often used in smartphones. Now we are utilizing planar antennas we are using because it's easy to make on the PCBs. Array antennas used for beamforming in base stations. Massive MIMO antennas characteristics, large scale arrays typically at higher frequencies. Challenges, increased power consumption and thermal management. Figure like so an advanced material for antennas if we see meta materials, flexible and transparent antennas, role of nanotechnologies. So what is the major thing? High performance materials we have to if we have to utilize the advanced materials for MIMO antennas, so we need high performance materials like dielectric substrates should be low loss material like loggers or Teflon for better signal propagation. Meta materials enable miniaturized and high gain antennas, flexible and wearable antennas, conductive fabrics and polymers for IoT and biomedical applications. Graphene based antennas, high conductivity, flexibility and potential for terahertz communication. 3D printed antennas. Now the printed tech electronics, like if you go IIT Bombay, IIT Delhi, also they have started now printed electronics. Means you just give the things directly, they print everything on the like on the polythene type of a structure. So this is like, because this is also type of an insulator, right? So this is also in a big demand. Even if you see edible electronics are there, printed electronics are there, organic electronics there, everywhere electronics are there, right? Because the major advantage of this printed electronics is the manufacturing cost is going to be reduced. So AI and machine learning in MIMO systems, so role of AI and ML, optimize signal processing and resource allocations, enhance beamforming precision using data-driven algorithms, enable real-time network adaptation to varying conditions. We actually, nowadays, there is a reinforcement, like RL, we are saying reinforcement machine learning, like type of things. So that is came now, so it is predicted everything by itself. So these type of techniques, when we come, so it's definitely the things are going to be like very like easy for the to make, like because everything is there, hit and trial based something they are doing like this, like this is replication channel estimations, AI based models predict and compare, because everything now predict, they will automatically predict and accordingly they will make the systems. Okay, so interface mitigation, ML techniques dynamically minimize interference, energy efficiency, AI helps optimize power allocation and reduce energy consumptions. So challenges, what are the high computational complexity, because the hardware is going to be very hard, right? So data availability for training AI models, integration with existing network infrastructures, and future scope PVC deployment of AI in 6G system definitely. So integration with edge computing for decentralized intelligence, self-heating network using AI for fault protection and recovery. Now we have seen the real world example. So already MIMO in where we or nowadays we are utilizing is, so MIMO in Wi-Fi deployed in modern routers like IEEE 802.11 AC and 802.11 AX standards. Already they have like included the MIMO. Enable simultaneous connection for multiple devices. Massive movement 5G network used by telecom operator like Verizon and AT&T to enhance mobile network capacity in the US. Supports applications such as live streaming, gaming, and IoT connectivity. Automotive applications enables vehicle to vehicle and vehicle to infrastructure communication for autonomous driving. like we are seeing the Tesla car and all those things. Satellite communications enhances signal reliability in satellite system for remote areas. So conclusion, what I said, because already 5 minutes are left. So MIMO and massive MIMO as cornerstones of wireless evolution. Antenna innovations driving next generation devices, endless possibilities for connectivity. I think this is enough. Because I understand you people also from last 3 hours around, you are continuously, definitely. Although this is my part. So thank you, madam, please, or if you, hello.
Thank you, sir.
Anup sir,
Yes, madam, I have finished actually. Yeah.
one minute. Sir, some question is there. Queries is there, sir.
Sir. Sir, good evening, sir. Hello.
Yes, sir, Avatar sir.
Hello. Hello, sir. Good evening.
Just 1 minute.
Sir,
Shall I?
Vivek sir, please type the question in the chat box.
Okay, okay, ma'am.
Hello, ma'am.
Yes, madam.
I too have some doubt, ma'am. Shall I ask question to sir?
Yes, madam. You can. No problem.
Yes, sir. Good evening, sir. Avatar, sir.
Yes, madam.
Actually, I am doing my PhD research on MIMO antenna system with the textile based, sir, material. And that conformability and comfort and efficiency, how it is the textile material is okay, or else any other flexible material do you have any suggestions, sir, regarding this?
Madam, actually the question is not clear to me well. Sorry.
Sir, see, sir, I am doing my antenna on flexible substrate. I have chosen my antenna with textile material, sir. Fabrication
Okay.
can be done by using jeans material.
Okay.
So to reduce and to enhance the parameters of antenna, can you suggest me the suitable materials for that, sir?
Ma'am, nowadays, actually see because you are using on the textiles. Actually, see, I'm telling you very clearly. This is not my like research area. Yeah, but my research area is particularly I'm working on semiconductors very well. So what I believe, because this is type of isolations materials we are utilizing for that one, if I'm not wrong, right? Like if you are working with the textiles, like you are using some textile for making the antenna, if I'm not wrong, right?
Yes, sir.
Like textiles, like cloth type, like something like this. It's like some type of we can say the organic type of a thing, right?
Yes, sir.
Organic material. So you are working on some organic type of a thing. So nowadays, what happens now, ma'am, when we are coming with these type of a things, now the metro structures and like combination of the structures. Because when we are working, because we can't suggest any material by not seeing the parameters. So what I am doing, like in my research, generally we are combining the materials. Like if we are going for the CC communications, particularly for the conduction, because there is an isolation. So what we are suggesting indium, like some type of a like ternary compounds. Like we are combining 3 and 4 materials together. And nowadays the technology is so much high, you can combine anything with anything. If you know about the integrated circuits and all those things, like we are putting the layers by layers. Right. We have a fabrication lab, you can put any layer on any layer. And when we are talking about the antenna, so the fabrication of like, because this is the work demanded by the environment, when we are working with the mixing of the like 2 and 3, like some material have some good quality, some material has some good quality. So
Yes,
what
sir.
my suggestion, you try in this way, it's a good thing. What my suggestion?
Yes, sir. Thank you so
I
much,
think
sir.
might be I am clear to you, madam. Yeah.
Yes, sir. Thank you, sir. Thank you.
Most welcome, please.
Hello.
Yeah.
Sir, as you told that there are some challenges, means the discussion, I understand that there are different challenges in massive MIMO, like pilot contamination, pre-coding, then energy efficiency. So which channel is means which is the most what we can say, a significant challenge in massive MIMO?
I believe that the pre-coding technique is because see there is a always when we are need more number of the things you understand my point, like pre-coding, because nowadays na we are just seeing the things before what is happening. So pre-coding techniques, what I believe, because the perception is different to different, it's different to different. So all the pilot contamination is also a big challenge. There is a no doubt. But means it depends on your what is your goal. If you want to publish the paper, so I believe pre-coding is very good. But if you want to go to the industry, then I believe the palette contamination is best. So, the thing should be clear. Might be I clear to you, madam. Yeah.
Sir,
Yes, madam.
sir, how can we achieve the energy efficiency in massive MIMO, sir? Because we are using more number of antennas, then how can we achieve the energy efficiency, sir?
Ma'am, actually the type of because actually I already told you I'm not like I know as per your level these things, but I believe that like adaptive type of a thing, like when we are using because there is a lot of research is going in massive MIMO also, right? So if we see around like something lean carrier design, sleep modes, like machine learning and all those things we have to implement together, then it is only possible. Because when we are talking about the efficiency, there is no single definition for the efficiency. There is all the
Yes.
ways by which we can able to control. So like adaptive massive messing, like machine learning, we use sleep modes, many things are there. Means there's no the direct path. But yes, there is a research opportunity on all the paths.
Okay.
Yeah.
Avatar sir, one more question from my side.
Yes, madam. Please.
Sir, can you differentiate application point of view with MIMO antennas for 5G as well as for 6G, sir? How, can you differentiate the applications, sir? How much efficiency is there in between the applications point of view?
No, ma'am, I am not clear about this point. Sorry. Actually, I haven't seen. Yeah.
Oh,
Because it depends. Actually, I'm telling you now, the questions are coming like efficiency point of view. Efficiency is the thing. It depends. Because 6G is still now, it's not implemented anywhere, what I believe. Right?
no
So,
problem.
yeah,
No
might be.
problem. Your session
Yeah.
is very nice, sir. Thank you so much, sir. Thank you, sir.
Thank you. Any other question?
sir,
One question is
complete
train the AI for channel estimation. Ma'am, many algorithms are there. If you see on Google, you are getting the more algorithm nowadays are there. I am not working on the AIs, but yes, like we know there are many algorithms out there, we can see, right? Yeah, please. Yes, madam. Hello.
Yeah,
Any,
Anup sir.
any further question from any participants? Please, they can ask now. Okay, I would like to say that thank you, sir, respected Dr. Avatar Singh, sir. I would like to express our sincere thanks to our speaker for delivering such an insightful presentation on emerging MIMO and massive MIMO antenna for next generation wireless device. Sir, your deep knowledge and engaging delivery has inspired us all and sparked the curiosity to explore the subject further. On the behalf of ECE Department, Samskruti College of Engineering and Technology, I extend our heartfelt thanks to our speaker, Mr. Dr. Avatar Singh sir, to take time out of his busy schedule and sharing your knowledge and experience with us. Thank you, sir. Thank you so very much for giving us your time and sharing your knowledge, sir.
Thank you, sir. Thank you, madam. Thank you, PJ sir also.
Thank you, sir.
If
Thank you, sir. Thank you, sir. Avatar sir. Thank you very much, sir.
Yes, ma'am. Thank you, ma'am.
Thank you.
Thanks a lot, please.
Thank
Okay, ma'am. Please.
Dear participant, please fill the feedback form and we can leave.
I will share the PPT with you. You can share with the participants. Okay, ma'am.
Yes,
Please.
yes, sir. Yes,
Thank
sir.
you.
Please, sir.
Okay.
Thank you, sir.
Thank you, sir. Thanks a lot. Please. I'm leaving, huh?
Yes, sir. Good
Thank
night,
you,
sir.
Good night from here, sir.
Dear participant, please fill the form. and you can leave. Tomorrow we'll meet.
Tomorrow is the 5th day of our program. At 6 p.m. it will start. So I request you all to join before that. Any queries and question about feedback or attendance, they can ask now. Otherwise, I can leave up the call.
Sir, I myself, Alekia, previously first day I missed that feedback form. Vanishri
Okay.
ma'am sent second day feedback, but unable to fill the first session's feedback link, sir, because
Okay,
of my.
madam. I will
Yes,
take care
ma'am.
of that. I will
Thank
see them, madam. I will see.
Thank you, ma'am.
Okay, we'll see.
Okay.
No problem.
Any doubt and confusion? Participants, please let us know.
Sir, we need PPTs. If you have any PPTs,
PPTs we will share,
Yeah,
ma'am.
we'll share, madam. We'll share after completion of all the session.
yes,
I will
ma'am.
send.
Yes.
I will send all PPT.
Thank
No
you so
issue.
much. Thank you, ma'am.
Okay, madam.
Okay, I'm stopping the recording.
Okay. Okay.
And now